Hello everyone, this is Abdurrahman Osama. I will be your TA in the Computer and Network Security course, and this will be our first tutorial. Today we will discuss classical cryptography. We'll be discussing various classical cryptography techniques. The goal of this tutorial is to have an understanding about what is cryptography and why we use it or why we care about it and how it was used in the old ages, basically. So let's start with our first cryptography technique. The first one we were going to discuss is called Caesar Cipher. So let's read the question. The question says, encrypt the following plain text using Caesar Cipher with key 8. And the plain text is resist much, obey little. So let's start by discussing how Caesar Cipher works. So the first thing we will think about is what are the givens and what do we need to do and how to do it. So what are the givens? We have the plain text and we have a key here, the key 8. Okay, what do we want to do? What we want to do is to generate a ciphertext. A ciphertext means a ciphertext is an encrypted text, means an unreadable text that can be returned back using a decryption technique to the original or the plain text. So what we want to do is to generate a ciphertext from this plain text here. So the only given that we can use is the key. So how can we use this key, or how is it used in Caesar Cipher? The key here represents the number of shifts in the alphabetic order. As you can see here, these are the English alphabet. What we will do here to generate our shifted alphabet for the ciphertext is that we will shift right 8 times here, since the key is 8. Meaning that we will take the last 8 letters and put them at the first here, at the beginning. 1, 2, 3, 4, 5, 6, 7, 8. So from S to Z should be here. So S, T, U, V, W, X, Y, Z. Then we take the rest of the letters here, A, B, C, D, E, F, G, H, I, J, K, L, N, O, P, Q, and R. As you can see here, we stop at R since S and the rest of the letters are here at the beginning. So what we want to do now is to generate the ciphertext using this new shifted alphabet. What does this mean? How can we do this? So basically, we will search for the letters that create this word in the shifted alphabet and get their original alphabet and put it back down here. How can we do this? Like this. The cipher is. So let's start with the first letter, which is R. We go and search for R here, which is this one, and we substitute it with the corresponding letter here from the original alphabet. So it will be a Z. The next one is E. We search for E, which is here, and we get the substitute alphabet, which is M. Then we go for and search for S, which is here, and we replace it with A. Then we search for I, which is here, and we replace it with Q. S is an A also, like the old one, and we search for T. So T is here, we replace it with B. Now we are done with the first word. Let's go to the second word, much. Let's search for M. M is here. We replace it with U. Then we have U. We search for U here, which is here. We replace it with C. Then we have C. We search for C. We replace it with K. And then we have H. We replace it with B. Now we're done with much. Now with obey, we search for O. O gets replaced with W. Then we have B. We search for B. Replace it with J. Then we have E, and we replace it with M. Then we have Y, and we replace it with G. Now we're done with the third word. Now little, our last word. We search for L. We replace it with T. We search for I, and we replace it with Q. We search for T, and we replace it with B. And we search for L again, and we replace it with T. And finally we replace E with M. And we're done. We have our ciphertext. Now, what if we want to get it back to the original text? What do you think you'll do? If we have only the original alphabet, as usual, we need to have the key so as to do the shift and get this shifted alphabet. And what we will do now, we will go and search in the original alphabet and get the corresponding letters from the shifted alphabet, meaning that this R became a Z. We go and search in the original alphabet for Z and get the corresponding letter in the shifted alphabet, which will be R. Doing this with all the letters will get us back to the original text. Now with the second question, also with Caesar Cipher. Decrypt the following ciphertext using Caesar Cipher, knowing that the key is less than 5. See what they did here? So the question here does not give us explicitly the key. It just gives us a range. So it just says that the key is less than 5. This means that the shift that we will do will be less than 5. So let's start thinking about how many shifts can we have. What do you think? We have in total 26 letters. So in Caesar Cipher, we can have a maximum of 26 trials to come up with the correct plaintext from any ciphertext. So it's not really secure. So the question here narrows down the search for only 5 moves. Let's start using some cryptanalysis techniques to think about what would be the best fit here for the key. So one thing I would think about would be the following. I can see here that the sentence here starts with an M, all left alone, with nothing next to it. So from our knowledge with English, so we assume here that the text written is in English. So in English, there are 2 common letters that are usually used alone. It's A and I. So let's just try to see how many shifts do we need in order to be able to replace M with I. or let's start with A. M and A. As you can see here, the shift between M and A is definitely bigger than 5. So it's not an A. Let's go and check I. The shift between them is what? 1, 2, 3, 4. So it's 4. So we just need 4 shifts in order to replace M with I. So let's try to write the shifted alphabet. Now, I will start with I here, since this is exactly what I want. Then I will continue writing the rest of the alphabet. J, K, L, M, O, P, Q, R, S, T, U, V, X, Y, Z, then A, B, C, D, E, F, G, H. Okay, I think I've done something wrong. Did I miss something? Okay, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. Oh, I forgot the W here. So, just let me erase this. V. So we have here. Wait a minute. We have here W, X, Y, Z, then A, B, C, D, E, F, G, H, and it's all good. So now let's try to decipher our ciphertext. So the first thing I will do, I will go and check here the M, and I will replace it with the I. So it will be I. Then I will go and search for the X and replace it with T. Then the L and replace it with H. The M and replace it with I. The R and replace it with N. The O and replace it with K. And put the comma. X, replace it with T. L, replace it with H. I, replace it with E. V, replace it with R. I, replace it with E. J, replace it with F. S, replace it with O. V, replace it with R again. And I, replace it with E. Now with the M, I replace it with the I. And then the I, replace it with E. B, replace it with X. M, replace it with I. W, replace it with S. And finally, X, replace it with T. I think, therefore, I exist. And we were able to decrypt it. Now with the next question. Now we're having a new cipher technique. It's called the Monoalphabetic Substitution Cipher. This one is straightforward. It's very easy actually. So what we do here, as you can see, we don't have a key, we don't have anything. We only have a cipher alpha, meaning that the thing that should be exchanged between the parties encrypting and decrypting messages here should be cipher alpha that they create for their own. So here we have the plain alpha and the cipher alpha, and we should use them to decrypt this ciphertext. So what do you think we should do? This is the ciphertext. So it's created using the cipher alpha. We want to get the plain alpha. So you will go and get the letters here. We start with I and search for them in the cipher alpha and replace them with their corresponding letters from the plain alpha. So I would be U and D would be N. O would be B. W would be E. A would be I. D would be N. E would be G. F would be D. W would be E. L would be A. And F would be another D. A would be I. T would be S. D would be N. B would be O. Y would be T. Then O would be B. As you can see here, this is just the same like this, so we can take it from here. It's being. And finally, L would be A. P would be L. A would be I. U would be, can't find U. U would be V. And W would be E. And we're done. And being dead is not being alive. Should be easy. Now, with the next cipher technique. This one is called Vigenere Cipher. It can be somehow tricky, so you have to be careful. So let's start by reading the question. Here it says encrypt the following plain text using Vigenere Cipher with key play. And we have the plain text attack now. So let's start thinking about our givens. We have a key, and the key here is not a number anymore, and we have the plain text which is attack now. How can we use these givens in order to come up with a ciphertext? Well, in Vigenere, we have a cipher table that's specially made for this ciphering technique. And here is it. It seems too big and it seems weird, but in fact it's really easy. So let me show you how it works. So the first thing we need to know here, or we need to do in order to start the encryption process, is that we need to start writing the letters here in the plain text like that. A, T, T, A, C, K, N, O, W. And we start repeating the key here all through the letters in our plain text. Sorry, pardon me. So let me start doing it. We have P, L, A, Y, P, L, A, Y, P. So far so good. Now we are ready to use the table in order to come up with the ciphertext. So what we do here, we start taking every two letters from the plain text and the key against each other. This is the plain text and key. And we want to get here the cipher. So let's start with A from the plain text and P from the key. We search here in the plain text, we search in the columns, and for the key we search in the rows. So we said we have A and P, A plain text and P in the key in the key. So we replace it with P. So here it will be P. Now we have T and L. We search for T, we have it here, and we go and search for L. So here we go here, and we go like this here, and we have E. So the next letter will be an A. Now we search for T and A. We search for T and A, it's a T. And now we search for A and Y. Search for A and Y, it's a Y. We search for C and P. Search for C, and we go down to P, it's R. So here is an R. We search for N and A. Search for N, and we go to A, so it's also an N. Pardon me, we forgot K and L. K and L is a V. It's not an R, it's a V. And we have N and A, which was an N. We have O and Y. O and Y should be an M. And we have W and P. It should be an L. And that's it. We have our ciphertext. So let's try to do the exact opposite, to decrypt something. So now we have the key and we have our ciphertext. The first thing to do, just as we did in the encryption process, we type down all the letters here we have in the ciphertext, and we type down the key and keep repeating it beneath the letters. So let's start. It's L, L, V, Z, H, P, K, I, M, B, U, S, W, U. And we start repeating the key here, senior, S, E, N, I, O, R, S, E, N, I, O, R, S, E, N. So this is our cipher, and this is our key, and here we will write our plain text. Let's start. So what we will do here, our search will be a bit different. So if you can remember, this row here contains the plain text alphabet, this here contains the alphabet for the key, and all the rest of the values inside here are for the cipher. Correct? So in the decryption, let me show you how we search. Let's start with the key S and the ciphertext L. So we have L and S. I will go and search for the key S, then I will go here and search for L. I will go up here and get the corresponding value. So the first one will be T. I will do the same to all the other letters. So here we have E and L. I will go to E and stop at L. So I'm searching for L here. Here is L, so it's H. So I have here H. I have N and V. So I have N. I go search for V, and I go and take the letter here, which is I. Then I have I and Z. I go and search for I. I go to the key I and search for Z, so it will be R. Pardon me. So I go and search for O and H, O, and I get H, so it will be T. Then I go and search for R and P, R. I go and search here for P, so it will be Y. Then I go and search for S and K, S. I go and search for K, and it will be S. Then I go and search for E and I, E, I is E. Then N and I, N and I is V. Then I and M, I, M is E. Then O and B, O and B is an N. Then R and U, R and U is a D. Then S and S, S and S is an A. Then E and W, what's wrong? E and W is an S. And N and U is an H. So here we have our plain text 37 dash. So now the next ciphering technique. The next one here is called rail fence cipher. So how does this rail fence cipher work? Let's start by reading the question. So the question here says, encrypt the following plain text using the rail fence cipher with key 3. And we have our plain text. Creativity is knowing how to hide your sources. So we have a plain text and we have a key value. So what we need to do here is basically to start knowing how to use this key. How can we, what does this key represent in the rail fence cipher? So basically, in the rail fence cipher, the key represents the number of columns I will be, the number of rows, sorry, I will be using to distribute the letters in my word in order to generate the ciphertext. What does this mean? We have here key 3, meaning that we will distribute this plaintext, the letters in this plaintext, upon 3 different rows. How will we do this? Just like that. C, creativity here will be C, R, E, A, T, I, V, I, T, Y, I, S, K, N, O, W, I, N, G, H, O, W, T, O, H, I, D, E, Y, O, U, R, S, O, U, R, C, E, S. Creativity is knowing how to hide your sources. So what we do next is that we take each row here all together, not as columns as we did, and we combine them together. So this goes then this, the second one goes after this, and this goes after this, just like that. So let's see how can we decrypt something encrypted in the real funds cipher. So here the question says decrypt the following plaintext using the real funds cipher with key 2. So key 2 here means that this ciphertext was done on 2 rows, correct? So what we will actually do here, we will we will count the number of letters here and we'll divide it by 2 and put each half basically in a row. So let's start counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so 21 divided 2, it would be 10.5. So what we will do, we will round up. Here we will always round up, not down. So it will be 11 letters in each row, and we will have an empty slot in the second row, meaning that it will be like this. We will take the first 11 letters in the first row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll stop here. So it will be like this: P, A, E, E, I, S, I, H, S, I, E, E, C, B, G, N, W, T, A, M, L. And we will read it just as we wrote the previous question. So here I will read it like that. Peace. Let's try to change the color. As you can see here, peace begins with a smile. Should be easy, correct? Now, with the next technique, which is the row transposition cipher. So let's start by reading the question, and then we discuss how to use this cipher technique. So the question says, encrypt the following plain text using the row transposition cipher with key 7521346. So how can we use this key, or what does this key denote? So the key here denotes the order of the columns. What does that mean? You will see this in the encryption process. Bear with me. So, how to use word transposition? Let's start with the first step, which is writing down the key here, like that. 7, 5, 2, 1, 3, 4, 6. Now, the next thing that I will do, I will start writing down the letters here, row by row, just like that. W, H, A, T, E, V, E, R, Y, O, U, A, R, E, B, E, A, G, O, O, D, O, N, E. And as you can see here, we have 4 empty slots. In row transposition, what we usually do here, we pad by any kind of letters. Let's say we will pad with A, B, C, D, for example, or W, X, Y, Z, or 4 A's, or any padding technique. Or you can pad using any letters. So, what we do next, we start taking the letters and putting them into one line, but using the order of the columns, meaning that this is the first column, the column number 1. So we take these 4 letters first. So it will be T, U, G, A, then A, O, A, E, which is the column number 2, then the column number 3, which is E, A, O, B, then column number 4, which is V, R, O, C, then number 5, which is H, Y, E, N, number 6, which is E, E, D, D, then number 7, which is W, R, B, O. And we're done. Let's try the decryption of the row transposition cipher. So what do we have here as given? We have the key and the ciphertext. So what do we do? What do you think? So the first thing we need to do here is to start distributing the ciphertext among the 3 columns. So how can we do this? We also count the number here, the number of letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 divided by 3, meaning that we will have 4 letters in each row. And we have 3 rows here, as you can see. So since we take here in the encryption process the letters using the order of the rows, the columns in the key, what we will do here, we will start writing, we will not start by writing down the correct order or the key order of the columns. We'll just start with 1, 2, and 3, which is the correct order of the digits. So we will start writing down, filling each column with 4 letters, like that. K, A, T, A, H, U, M, A, N, A, T. Then what I will do now, I will shuffle the columns so that I have the correct order here, like the key. So what I will do here, I will take the second column to be the first one, so it will be H U M A, which is number 2. Then I will take the third one and put it here, A N A T, be number 3. Then I will take the first one and put it here, which is K A T A. Now let's start reading the same way we wrote the letters in the encryption, which is row by row. As you can see, HAK Hakuna Matata. Easy peasy. Now with the 10th question. So here, let's start by reading the question. It says encrypt using monoalphabetic cipher with the below substitution key, then row transposition cipher with key 361425. So what we're doing here, we're using multiple encryption layers. What does this mean? It just means that we will do multiple, one or more encryption. We will use one or more ciphering or encryption techniques in the same pipeline. So here we will start by encrypting this plaintext using monoalphabetic, using this table. Then we will take the cipher output from the monoalphabetic and re-encrypt it again using the row transposition cipher. So what do you think we should do if we want to decrypt this, the output of such algorithm? What order would we need to use to decrypt? Actually, since we start with the monoalphabetic, then we continue with the row transposition. We have to decrypt the row transposition first, then we can decrypt the monoalphabetic. So we just go in the reverse order. So let's start solving this question. The first thing we need to do is to start searching for the letters here in the plain alpha and substitute them with cipher alpha. So A would be S, T would be D, A would be S, C would be H, K would be K here would be A would be S, T would be D, D would be I, A would be S, W would be M, and N would be Q. So we're done with the first step, which is encrypting using monoalphabetic. So we have C1, which is the first cipher. Now we do the next step, which is the row transposition. So when encrypting using row transposition, what we do, we start by typing down the numbers of the columns, which is 3, 6, 1, 4, 2, 5. And then we start filling them row by row. So it's S, D, D, H, A, S, D, I, S, M, Q. Now, according to the order of the numbers, here we start taking the letters into our cipher C2. So the first column contains D and I, so it will be D, I, H, M, second column here, then SS, which is the third one. The fourth is also SS here. The fifth contains A, Q, the sixth contains D. And we're done. We have our final cipher. Now with the question 11 and our last question for this tutorial. Now let's start reading the question. Decrypt knowing that the following text has been encrypted using Vigenere Cipher with the key Harry. Then real fence cipher with key 3. So it was encrypted using the Vigenere Cipher. Then it was encrypted using the real fence cipher. So in order to be able to decrypt it, we have to start with decrypting the real fence cipher. So we can have the ciphertext output from the Vigenere Cipher. Then we use it to decrypt the Vigenere Cipher and come up with our plain text. Let's start decrypting the real fence. So let's try to remember what we do here. In real fence, we have the key here, which is 3. It denotes the number of rows. So we have here 3 rows. So we need to divide our ciphertext here into 3 rows. So I will just do it. It will be A, S, W, J, V, then H, M, Y, P, U, then V, F, F, V. So, how do we read the real fence? I will just remind you. We read it like this. Remember? So here the output will be A, H, V, S, M, F, W, Y, F, J, P, V, V, U. This is the decrypted cipher from the real fence, and this should be the output cipher of the Vigenere encryption. Now we have to decrypt this ciphertext using this key and the Vigenere table. So what we do here, we start typing down the key multiple times here, like that. Did I forget something? Let me check. EH, VS, so we have this. So I guess I forgot something. Let me just double check. AH, V, S, M, F, W, Y, F, J, P, V. Okay, I forgot something here. Let me correct it. So after the W, Y, F, we have J, P, V, V, U. So here it will be Harry, like that. And then H, A, R, R, like that. Okay, so what we do next, we go and compare the key and the cipher we go and get search for the key and the cipher letters to get the plain text from the Vigenere table. So I think I don't need to do this again with you, so I will just put the result here to be T H E B O Y W H O O I V E D, which is the boy who lived. This is it. We are done with our first tutorial. I hope you understood everything. If you have any problems, you can contact me through email or any other means of communication that will be at your help. Thank you so much. See you next tutorial. Bye bye.